Okay, let's solve a quadratic equation. Well, first I'm going to write down the quadratic formula. So the quadratic formula says if ax squared plus bx plus c equals 0, then x equals the opposite of b plus or minus the square root b squared minus 4 times a times c, all of that scaled down by double A. Okay, so I recognize that the first thing I really should do is write down ABC. No. Step 1, set equal to 0. I just remembered, right? This only works if it's equal to 0, and it is. So step 1, set to 0. Step 2, write down ABC. Here, A is implied to be 1, B is equal to -2, there are -2 x's, and C is equal to +1 because after that we add 1. Got it? I got my ABC. Check. 3, formula with order of operations. So, okay, I'm going to put formula. Right. So that is saying x is equal to the opposite of b, which is 2, plus or minus the square root. -2 squared is 4. But you know what I'm going to go? I'm going to go -2 squared minus 4 times 1. That's the a times the c. That's 1. And all over, I'm going to double my a. Okay. So what did we say with the order of operations here? Radicals value first. I'm on it. Okay. Okay, right. -2 got squared minus 4 times 1 times 1. 0. And just so that we're crystal clear, the square root of 0 is 0 because 0 squared is 0. Okay, so we just did the square root, or under the square root's value. So we did 2 plus or minus the square root of 0 all over double the a. And then we said take the square root. Square root of 0 is 0, so we have 2 plus or minus 0 all over 2. Radical value, root, add, subtract, then divide. Okay, well, adding and subtracting, super easy. It's just 2, and then divide. Yay! Okay, so here's step 3. Remember the order. And for solutions. Okay, so we write down our solution. The solution to this is x equals 1. And I want you to see this because what I love about that is that when we did the same problem but we factored instead, we still got x equals 1. So this problem could have been factored. We did it fairly quickly and we got x equals 1 with the either or scenario. And here we use this formula instead and we still got x equals 1. So that is good news. At least now we know that actually works. Okay, let's do it again. So, step 1, set to 0. Okay, step 1, set equal to 0. Check. I feel like we did this problem too. That's okay, we factored it. Step 2, ABC. A equals 2, B equals 17, C equals 21. Check. 3, formula. Paying attention to order. X equals the opposite of B, so -17 plus or minus the square root of 17 squared minus 4 by A by c, all of which is over double this a. Okay, then it said follow that order. What is under the square root? Okay, 17 squared minus 4 by 2 by 21. Ooh, 121. And then I'm going to take the root. Square root of 121, 11. Okay, so do what's under the radical. So the radicand is 121. Then take the square root. Oopsie, I don't know why I was about ready to make a 2, but it is not 12, it is 11. Okay, and by order of operations, the next thing we do is actually add and subtract. So I'm going to split this into an either or scenario. Ooh, la-di-da, there's still an either or here. So either x equals negative 17 plus 11 all divided by 4, or x is equal to negative 17 minus 11 all divided by 4. Uh-oh, I'm going to run out of space here. Negative 17 plus 11 is negative 6. Negative 6 divided by 4, that's negative 1.5. Here, negative 17 minus 11 is what? Negative 28 divided by 4. Okay, so even though it was a lot of work, now we have our solutions. Step 4, write our solutions. X equals negative 1.5, or x equals negative 7. Good. We agree with our factoring technique, but I see that our factoring technique may have taken less space and a little bit less work. Yeah? Set to 0, factor, do the either or. So, and it agrees with what we've done here. So set to 0, ABC, use the formula, and then see our two solutions. Okay, let's do number 3. Oh, right. Okay, step 1, set equal to 0. That is not done here, so we better do that first. We would have x squared minus 5x's plus 2 equals 0. I deducted 5x from both sides. Step 2, A, B, C. So A is 1, B is negative 5, C is 2. Step 3, formula with its order. So x is equal to positive 5, because that's the opposite of B, plus or minus the square root of negative 5. I just actually squared it on accident. Okay. Negative 5 squared minus 4 times A, which is 1, times C, which is 2. All over double this A is 2. Okay. Radicand. 5 plus or minus. What's 25 take away 8? 17. Okay, and now I'm going to have to round that. So 5 plus or minus square root of 17 is about 4.1. Okay, and now we do the either or. Okay, so either x equals 5 plus 4.1 all divided by 2, which would result in 9.1 divided by 2. which is 4.55 approximately, or x is equal to or approximately equal to 5 take away 4.1, which is 0.9, and then divide that by 2. Wait a minute, yeah. Should have just gone with my gut. So, and then we write our solutions. Oh, no wonder why we were having such hard time. I do remember saying that a half and 4 are pretty close to getting 5 because we got negative 4.5 in terms of our factoring business. But now it's becoming even more clear. It's because of the square root of 17 is so awkward. It doesn't even terminate. So this would go on and on and on forever and ever. And I would just keep trying to get a better, more accurate answer. But nonetheless, here we go. Here are 2 solutions. X is approximately 4.55, or X is approximately 0.45. Got it. And then number 4. Let's try this again. Okay. Step 1. Set equal to 0. Check. Step 2. A is 1. B is 5. C is 1. Step 3. Formula. X is equal to the opposite of b, so negative 5, plus or minus the square root of negative 5 squared minus 4 times 1, because that's a, times c, all over double this a, which is 2. Okay, what's 25 take away 4? 21? Okay, so negative 5 plus or minus, so radicand, 25 minus 4 is 21. Okay, now I need to approximate, so square root of 21, 4.6-ish. And now I'm ready to do either or. So either x is approximately, I'm going to go with subtraction or addition first, I don't know why. Negative 5 plus 4.6 is negative 0.4, and then divide that by 2. So either x is equal to negative 0.2, or x is approximately, now I'm going to go with subtraction, negative 5 minus 4.6 is negative 9.6. Split that in half and you get negative 4.8, about. Okay. Brava. I wanted to, when I'm hesitating before going on to example 4, just because I was thinking, if a had been 5, like 5x squared plus 5x plus 1, then we would have had, no, it would have to even be even more than that. Let's suppose for fun, this had been 7x squared plus 5x plus 1. Then this would be 25 take away 28, and we would have had negative 3 under this radical. And that leaves us with no solution. So just so you know, so far we've gotten 2, which is pretty nice each time. So we just said those would be our 2 solutions here. Okay, let's look at a real application. Consumption of bottled water in the United States. A quadratic model for the annual consumption of bottled water, which might have increased, by the way, this year, in the United States is consumption is equal to 0.0206x squared plus 0.0446x plus 2.2486. Got it. Numbers. Big accuracy there. where X represents the year since 1990 and C represents billions of gallons drank. Okay. Compute C of 3 and say what it means. First things first, so I see we are in function notation. And so this does not mean C times 3. This means X is 3. And when X equals 3, that's years since 1990. It's 1993. Okay, so right off the bat, that's what's happening. And when X equals 3, the consumption is 0.02063 squared plus 0.0446 by 3 plus 2.2486. Okay. If I ever saw something to do in my calculator, that's it. So that is what I'm doing right now, is I am literally typing in that entire number sentence, and I get 2.5678. Say what it means. In 1993, billions, let's turn this into billions. So, okay. 2,567,800,000 gallons of bottled water were consumed in the United States. Got it. That's a lot of them. Find the amount of bottled water consumed in 2014. Okay, so now we actually have to find the X. 1990 to 2000 would be 10 years, and then add 14 more, 24 years. And then we do the same thing. So C equals 0.0206, but 24 squared plus 0.0446 24 times plus 2.2486. Okay, 0.0206 times 24 squared plus 0.0446 times 24 plus 2.2486. Okay, I got 15.1846. Oh my gosh. Sorry, that's a lot. 15 billion gallons. Find the amount of bottled water consumed. Okay, so we'll just tag this. Billions of gallons. Whoa. Are there more questions? Of course. The actual number of billions of gallons consumed in 2014 was 15.42. Wow, that model is particularly close. Is this different than the amount you calculated in number 4? Yes. Why? Well, the why is because, so yes, why? Models aren't perfect. They are educated guesses based on data. So based on, sometimes on the processes at hand, but based on past data. Really, we're looking at the trends. What is the relative error? Ooh, which is also known as the percent change. So that's a formula. Percent change was the ratio of, let's see, I remember now. The new amount minus the, okay, new minus original. compared to the original times 100. Okay, so a formula from the past that is coming up now. Let's see. But this is, so we're going to use our model for the new amount, and we're going to use the original is actually 15.42, and this is the model's prediction. So new 15.1846 minus what it really is, 15.42 billions of gallons of water drank. Okay. And this is yet another plain calculator problem. 15.1846, take away 15.42. All of that should be in implied parentheses. So remember, order of operations, so there's implied parentheses here. All of that is divided by 15.42 because that's the reality. And scaled up by 100 to make it a percent is approximately negative 1.5%. Hey, that is not too shabby. Like when I saw that number compared to these two, I was like, our model did a pretty good job of guessing, actually. Use your model equation to predict when the annual consumption will reach 14 billion. Okay, so this was 15 billion, so previous to this one, but we need to figure out exactly when. Okay, so all of a sudden, we are not given the when, we are given the C. Yeah, C equals 14. So if we go back to our model, where was our model? Blah, 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 yeah. There it is. Okay, I see the model, and it says, we put in 14 for the C, actually. 14 equals 0.0206x squared plus 0.0446x plus 2.2486. I certainly see a quadratic formula in our future. I mean, look at that. I'm not factoring that. Sorry. I'm sure there's someone out there who's like, I'd be delighted to factor that. But step 1, set to 0. In order to set this equal to 0, I'm going to have to subtract 14. So I just made a mistake. I'm going to have to take my 2.2486 and subtract the 14. 2.2486, take away 14. That would be minus. So minus 11.7514. Got it. Because we needed to take away 14 from both sides of this equation in order to set it to 0. Step 1, set to 0. Step 2, ABC. So step 1, check. Step 2, ABC. Here, A is 0.0206, B 0.0446, C negative 11.7514, and now it's formula time. The opposite of B, negative 0.0446, add or subtract, square root of 0.0446 squared minus 4 times A, which is 0.0206, times C, which is negative 11.7514, all over double the A. 0.0206 times 2. 0.0412. Woo! First step, under the radical. And I'm going to root it actually. So I'm going to do all of that at once because I am about ready to be out of, I guess I could move it down here. It's a big problem actually. So let's see, 0.0446, that gets squared, keeping it in parentheses, minus 4 times 0.0206 times negative 11.7514, making sure that you remember all of your positives and negatives correctly. And that square root, I got approximately 0.985, pardon me. Okay, then we do our either or. I'm going to go like this. Whoop. Okay, so either, so this quadratic formula, it actually needs a lot of space and it has a lot of steps. So we only use it when we have to. So either x is equal to negative 0.0446 plus 0.985, all divided by 0.0412. Okay, which, by the way, and that's still an approximation. Let's do that. Negative 0.0446 plus 0.985, and take that quantity divided by 0.0412. Okay, so there I got x is approximately 22.8. And then here, this is the or, x equals negative 0.0446 minus 0.985, all divided by 0.0412. Okay, negative 0.0446 minus 0.985. Eli. Okay, dogs. Adorable, but he's actually been quite quiet, I must admit. And here I get negative 24.99 about, or about negative 25. Okay, so wait a minute. And then we have to say what our answer means in the context of this scenario. Well, here, this would be years before 1990, and I highly doubt that that is applicable in this situation in terms of popularity of bottled water. So 25 years before 1990, doubt the model holds. So model probably doesn't work. Yeah, I think the popularity of bottled water is, like, I mean, century-wise, relatively new thing. The idea of filtering water, however, is not. That we've been doing for quite some time. But 22.8, so that means that's years since 1990. So in about 1990 plus 22.8 years is in about 1967. Why? What is going on with my brain sack? All right, here. Today we have got to watch ourselves. 1967, by the way, is before 1990, and 2000, and I'm going to round that to whatever. I'll go 2012 to 2013. It's a little bit closer to 2013. It's 0.2 of a year away, but somewhere in between, in about 2012 to 2013, 14 billion gallons of bottled water were consumed in the U.S. So here, I'm going to put this right here. 14 billion gallons of bottled water were consumed in the United States. Okay, so let's kind of take a peek at what we were just talking about here. Yeah? So here's what I mean. In this section 4.10, we wanted to solve quadratic equations using a formula, and we really needed to motivate this by the fact that some things just simply can't be factored easily. It takes a lot of work to factor something like this. And then we wanted to make sure that we were able to interpret these solutions and apply them to an actual problem that we model from our real life. Okay, so we were able to factor some of these and make sure that this formula works. So here's a formula that you are definitely going to use. And at the end of the day, we really wanted to write down how can we use it, because here is a true reality of the use of this formula, where we had to find out, okay, when are we actually consuming 14 billions of gallons of water? Now, some of these make perfect sense to me for us to want to estimate, because all kinds of consequences come out of drinking these bottled waters, like recycling and people who don't recycle this and ends up in the seas, or like plastic bottles are a thing. And how about filtration systems and demand? So there's all kinds of implications and problems behind this. And so when we need a tool that can match its demand. We can't really factor this thing. It would take us forever to factor it. So then we bring out the bigger utility, and then make sure we follow the order of operations so that in the end we can actually answer questions pertaining to data that is modeled in more of a curvature nature instead of a straight line nature.